Hello everyone. Now we're going to apply what we learned in our last video to solving this linear differential equation. Okay, so the first thing I'm going to do is multiply the entire equation by our integrating factor, mu, so that we have mu times y prime minus mu times y is equal to mu times 2t e to the 2t. Okay, and now I'm going to recognize that this left-hand side here is just the expansion of the product rule of the derivative of y times mu, and that is true if mu prime is equal to minus mu, because we have the derivative of our first function times our second function, and then our first function times this must be the derivative of our second function. So now we have a differential equation in terms of mu. We can separate our variables, so we have mu prime over mu is equal to minus 1, and now we can integrate both sides, and we get the natural log of mu is equal to minus t, and solving for mu we get that mu is equal to e to the minus t. Okay, now that we have a value for mu, we can plug it into our equation up here, but leaving this side as just this product rule symbolization. And so we have y, and we know what mu is now, it's e to the minus t, so we have y times e to the minus t all prime is equal to e to the minus t times 2t e to the 2t. Okay. This e to the minus t times this e to the 2t is going to make just an e to the t. So we have y times e to the minus t all prime is equal to 2t e to the t. Okay, now we can integrate both sides again. And the integral of a derivative is just the function inside, fundamental theorem of calculus, y e to the minus t. And then to integrate the right side, we need to use integration by parts. So I'm going to let u equal 2t, and du then is going to be 2 dt, and dv I'm going to let equal to e to the t dt, so v is then just e to the t. Okay, now we're ready to plug into our integration by parts formula, which is u times v minus the integral of v du. So u times v is going to be 2t e to the t, and that's going to be minus the integral of v du, so e to the t, and that's du is 2 times dt. So I'm going to bring that 2 out here. So we have the integral of e to the t dt, and that's just e to the t. So we then have y times e to the minus t is equal to 2t e to the t minus 2 e to the t plus c, or constant of integration, because we have no initial conditions, no bounds on our integral. So we need a constant of integration there. And now for the finishing touch, to solve for y of t as an explicit function of t, we multiply the entire equation by e to the t. So we have y of t will then be equal to 2t times e to the 2t minus 2 e to the 2t plus c times e to the t. And that is our general solution.